Transforming expression. Before we actually transform expression, I want you to see these two monomials and, there you go, and think about what are in common, right? So you see x and you see some other common factors. So if we factor this into, we can rewrite this 9x cubed as 3 times 3 times x times x times x, right? And then you can rewrite 15x as 3 times 5 times x times x. So this process is called prime factorization, right? So each of the factor here are not breakable. These are all prime numbers except x's. Now, what do you see in common? What we see in common is one copy of 3, one copy of x, and second copy of x. So the greatest common factor of these two monomial is 3x to the third power. No, actually second, because we have two copies of that. Now, let's factor 9x cubed minus 15x to the second power. Let's transform this expression into another form using this greatest common factor. So we can take these 3x cubed, 3x squared from these two things, right? Because it's in common. After I take these out, what's left for 9x cubed will be 3x. And after you take out 3x squared from 15x squared, only 5 is going to be left. And then we have subtraction symbol here. So 3x squared times quantity of 3x minus 5 is the transformed expression of this one. And we can always go back from this expression to this way by using distributive property. 3x squared times 3x is going to be 9 times 3 copies of x's. 3x squared times 5 is going to be 3 times 5 is 15, and we have x squared, and then we have subtracting. So process from here to here is called expanding. But process using distributive property backwards is what we call factoring.